On Python series. This is going to be one of the final episodes for working with series. Now, in the next video, we will be specifically focused upon data frames. So this will be one of the last videos for data series. And as you might have remembering, as you might be remembering, we had already done how to initialize. Let us cover what we had already done. Right. So this is what we have already done. We have already done what is a data series, what are its properties, and we had seen the syntax for a Python series, and then we had seen that how can we initialize a series using different methods, and we had discussed about empty series, how to initialize with Python lists, how to initialize with Python dictionaries, NumPy arrays, and scalar values, right? So you might be remembering that in the last video, while we were doing Python dictionary, I had given an assignment for you to solve and keep it with you so that we can discuss the answer in the next video. Today is the day when we are going to discuss that video, to discuss that problem. It was a very simple problem. Now we have to just look at the problem and understand what is the query and what is the output which we are going to find. Now this is basically to test how well you have understood the concept of initializing a data series using different kinds of data structures. The one we are discussing here is a dictionary, and in this question we find that there is a dictionary with 4 players name, that is Sachin, who has scored 50 runs, Dravid has scored 100 runs, Ganguly has scored 55 runs, and Dhoni has scored 60 runs. And we find that we have tried to create 2 series out of them. One is the D series, which contains the values from the dictionary, where the key values are Ganguly, Dhoni, and Sachin. So the output for the following program, where for the following dictionary, should be something like this. We'll see the actual output, but the output for the following program should be Ganguly, and then a space, and then we get 55, right? Then we find Dhoni, then there's a gap, and then we find 60, and then we give Sachin with a gap, find 50 runs, right? So this should be the output for the data series, D series, okay? And here this is column number 0, and this is column number 1, and this is the index values. Ganguly, Dhoni, and Sachin are the index values, right? And in the end, what would be written? It would be written D type colon int 64. Why? Because all the values which we have provided, 100, 50, 55, 60, all these are integer values. So that is why the data type will be int 64. Now, in the second data series, we find that we are using the same dictionary for making this series too, but we are using the index values MSD, Ganguly, and Dravid. So for these 3, what will be the output of the problem? We know that Ganguly is present in the dictionary, so it will give me 55. Dravid is present in the dictionary, so it will give me 100. But is MSD present in the dictionary? No. There is nowhere it is written MSD. MSD is written nowhere. So we don't have an input in the dictionary for which we can correspond MSD index value for. So what are we going to do for that? It is very simple. Again, the output should be something like this. Let us see. The index is 0. The first column is 0. Second column is 1. The first column has index values. First, the index value is MSD, right? Then the next index value is Ganguly, and the third index value is Dravid. Now, as we said, for Ganguly, the value which is there is 55, right? For Dravid, the value is 100. So we know that these values are present. But what about MSD? what value should come here? What value should come here? Yes, you guessed it right. If you have followed through the video last day, you might be understanding that whenever there is no values present in the dictionary for which we are using a index value, we know that this will be replaced by something which is known as NaN, right? And since this is replaced by NaN, this will become 55.0, this will become 100.0, and finally the D type of the program, the D type of this output should be float 64, right? Let us see the output and understand ourselves. You see, this is the output we get. Ganguly 55, Dhoni 60, Sachin 50, D type in 64, which we found for the previous one, this one. And for the next one, we find MSD NaN, Ganguly 55.0, Dravid 100.0, and D type is float 64, as we had seen here. Okay, clear with the answer? I hope you are satisfied with the output and the explanation of mine why this output is going to come. So now today what we are going to do is we are going to discuss about some of the things which are operations on the data series which are present. Okay, so what are the operations? Okay, we are discussing what are the operations which are possible on data series. So first of all, let us randomly create two data series, S1 PD dot series, and we are creating a random series 10, 20, 30, 40, 50. Okay, and then there is S2 with PD dot series, and it has the values 1, 2, 3, 4, 5. Okay, so these are the two series which we are creating, series 1 and series 2. Now the operations we are going to look at is addition of two series, subtraction of one series from another, multiplication of two series, division of one series by the other. These are the four operations which we are going to look at first. Then we'll look at some other operations as well. Okay, so let us begin. The first operation is addition. Now when we are discussing about addition, it is very simple. We can just write S3 is equal to S1 plus S2. This is the basic answer for addition. So what it does is it basically takes the two series with the values 10, 20, 30, 40 and 50 and adds the corresponding values of the second series. That is 1, 2, 3, 4, and finally it will add 5. Okay, so this will be the basic output for the addition. It won't print like this, it will print the calculation obviously. So it will print 10 plus 1 is equal to 11. It will just print 11. Okay, this will print 12, no, 21, 22. This will print 33. This will print 44. And this will finally print 55. Okay. So it is basically what it is doing is it will print these values for the data part. And what will be the index positions? The index positions for S3 will be 0, 1, 2, 3, and 4. So these are the index values, and the thing will be printed is 11, 22, 33, 44, 55. These things won't be printed. This is what I'm showing for you to describe what is going to happen. So it is taking one element from this, another element from this, and it is adding them up. Element by element, it is adding them up. Similarly, for subtraction, if we write S4 is equal to S1 minus S2, so you know that the output will be what? It will be similar to the output which we found in addition. So it will print 0 and then it will subtract 1 from 10. So 10 minus 1 is equal to 9. Then for 1, index position 1, it will be 20 minus 2 equals 18. Then for third position, that is 2, it will print 30 minus 3 equals 27. Then for the index value 3, it will print 40 minus 4 equals 36. And for the fourth position, it will print 50 minus 5 is equal to 45. Okay, so this will be the output. For multiplication, again the same thing, 0. For it will be S5 is equal to S1 star S2. So you know what the output will be, and for division it will be S6 is equal to S1 by S2. So all kinds of arithmetic operations which are possible in Python is also possible in Python pandas, and for every operation which we perform on Python pandas, it will be like series versus series, series divided by series will be element by element division, 10 by 1, 20 by 2, 30 by 3, 40 by 4, 50 by 5, something like that. So element by element it will divide. Let us see the 4 outputs. Print. Okay, let's do it like this. Series 1. And then we print the series. Print S1. Similarly, we print the other one. Series 2. And we print S2. Now, we print S1 plus S2. Print S3. Then we print S1 minus S2. S4. Okay, so let us print the outputs and see. You see, this is the output which we have found. So series 1 is 10, 20, 30, 40, 50. Series 2 is 1, 2, 3, 4, 5, as we had discussed here. Series 2 is 1, 2, 3, 4, 5. Series 3, which is the addition, S1 plus S2, is 11, 22, 33, 44, 55. S1 minus S2 is 9, 18, 27, 36, 45. And you know the others, what it will be. So you see, while division, we are doing single division, so it is float division, and it is why the data type is float. Okay, so I hope this is very, very clear, right? But I want to discuss about the elephant in the room. You see what is common here? What is so common, that is why these operations are becoming so simple. The only thing which is common here is the index values. The index values for series 1 and series 2 are the same. So the index values which are here is 0, 1, 2, 3 and 4. Similarly for series 2, the index values are 0, 1, 2, 3 and 4, right? Now my question is, what if we change the index values and see what are the outputs which we are getting? If we write index is equal to 1, 2, 3, 4, 5, and here we are giving index equals to 6, 7, 8, 9, 10. These are the index values we are giving. So 5 index values here and 5 different index values here. So do you think the addition will be happening? No, the addition won't be happening. So what will be happening? If the additions are not possible, because what it was doing is it was searching for the similar index positions and it was finding two values and then adding them up to create another value, right? So index position 0 contained 10 in series 1 and index position 0 contained 1 in series number 2. So when it was finding the index value 0 in both the cases, so it was taking both the values, adding them up and putting it in the index position 0 of series number 3, right? And similarly the other positions were also happening. Now what we are doing is basically we are changing the index values 1, 2, 3, 4, 5, making one index, one series having index values 1, 2, 3, 4, 5, and the other series having the index values 5, 6, 6, 7, 8, 9, 10. So completely different index values for both the series. We are not having any common values. Okay. No, I have to keep in mind that we are still making some additions, and I want to give you this right at the top of my head that pandas won't create any kind of a problem, any kind of an error. It won't throw any error while doing this arithmetic problem. Now, why is that so? We have to discuss what is happening behind the curtains so that we actually understand what the output for this program would be. When we have different index values, we have to understand what is happening behind the curtains. It is taking, as I told you, the index values should match with each other, right? We had told that for index value 0, it was searching for another index value 0 in the series number 2. Right, it was taking index value 0 from series number 1 and it was searching for index value 2, index value 0 in series number 2. Right, here the case is different. So when it is searching for index value 1, this index value 1 is not present here, but we are still doing the addition, right? So I want to show you something. Okay, you remember we had studied sets in mathematics. So this is a set for series number 1, and let me change the color. This is a set for series number 2. These are the two sets. Now one set contains, this second set contains the values 1, 2, 3, 4, 5. These are the 5 values which are present in this set. And the first set contains the values 10, 20, 30, 40, 50, right? So these are the 5 values which are present in series 1. This is S1 and this is S2. right? So these are the two series which are there. So we are finding that these are the values which were present. When the index values were similar, what are we doing? We are adding them up. So what we basically did was nothing but take a commonality, and then this was index value 0 and 0, added them up and found out the output, right? At this point, the index values are different. Let us write the index values down as different index values. Okay, so the index values which we have right now is 1, 2, 3, 4, 5 for this. Let's match it. 1, give it 1 minute. Let me just match them up. 1, 2, 3, 4, 5. These are the index values which are present, right? And similarly here, the index values are 6, 7, 8, 9, and 10. These are the index values, right? Now, since we have to add both of them up, we have to create a summation. We have to do a sum, right? Since we have to do a sum, we just can't leave out any of the values from the universal set S1 plus S2. Okay? We can't leave anything out of this set. Okay? We have to include everything while doing the addition. As I said, there won't be any kind of errors which are there. Okay? So while there are no errors, what is basically going to happen? It is very simple. It will generate some dummy index positions 0, 1, 2, 3, 4, and 5 here in series number 2, because it is searching for series 1 is searching for an index value 1, and series 2 is not having that index value, so it will create a dummy index. Okay, dummy index. And these dummy indexes will contain, what will it contain? This has to contain something, right? It is containing something which is not present. And we know from data series that whenever something is missing in a series, it is getting replaced by NaN. So all the 5 positions will contain values NaN. All the 5 positions will contain the values NaN. Okay, the same thing is going to happen here also. Some dummy values will be created for the index position 6, dummy index position 6, 7, 8, 9, and 10. These dummy index positions will contain values NaN all over. Okay, I hope I am making some kind of sense. You will really get to know what is going to happen. So when we are seeing this, these has some dummy values and these have some dummy values. Now you see the set is complete. 1 is present in series 1 also, 1 is present in series 2 also. 2 is present in series 1 also, 2 is present in series 2 also. Similarly, position 6 is present in series 2 also, and position 6 is present in series 1 also. But the values, what are the values which are present? Like position 1 contains the value 10, but position 1 in series 2 contains the value NaN. So now 10 will be added with not 1, but it will be added with what? It will be added with NaN. Similarly, 20 would not be added with 2, but NaN. And so on and so forth. But the interesting part here is it won't stop here. First of all, the index values are not 0. It starts with 1, then it becomes 2. Okay, no, this is okay. This is okay because this is the index values for series 3 and we are not changing the index values for series 3 anywhere. right? So it will add this up, but the funny thing is it will create 5 more rows as well, with 5 containing the values 5 containing the values position 6 plus position 6, which is 1 NaN plus 1. Why NaN here? Because we are taking the values from series 1 here, right? This is series 1 and this is series 2, right? For these positions, position 1, 2, 3, 4, 5, the series 2 did not have any values. Here, the series 1 doesn't have any value, but the series 2 does. Then position 6 will contain same NaN and then plus 2. Similarly, position 7 will contain NaN plus 3. Position 8 will contain NaN plus 4. And finally, position 9 will contain NaN plus 5. Okay, so this is going to happen. Now the funny part is when you are trying to add an integer with a none value, you are expected that it should throw some kind of an error. But I told you, pandas is smart. It doesn't throw any kind of an error. We know that whenever NaN is present, we have seen that whenever NaN is present, then the data type of the total series converts to float 64. That means NaN should be a float value, right? So here also it will treat NaN as a float value. However, since it doesn't contain a specific value, the resultant value should also be NaN. So the resultant value should also be NaN. Am I making myself clear? I hope so. This is a little bit more complicated, but I thought that since your curious mind might think that what would happen if we change the index positions, so this will be the output, and this will be the output for everything. Every output will become NaN. Why? Because any operations with NaN will be Na and N. So it will be none values. Any operation, that is plus, minus, into, divide, power, anything you do, the output will now turn to NaN. So the position, the addition will also give NaN, the subtractions will also give NaN, multiplication will also give NaN, and all the other types will also give NaN. Notice here what happened is, okay, this is very interesting what happened. For series 3, which is the addition series, I told you that the index position should be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But what it did was it basically borrowed even the index values from the given series. So the index values were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Up till 10 the index positions were there. Here 5 index positions, 1, 2, 3, 4, 5, and here 5 index positions, 9, 10, 6, 7, 8, 9, 10. So here also the index values became 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the summation will be having the index positions 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Subtraction will also contain these values with NaN as their data. Similarly for the other values as well. Isn't it interesting? It is very interesting how we see that addition of a integer with none value will give the output as none value. Okay. Okay, come on, let's move to the next thing. Okay, come. Now, since we have already done the summations and subtractions and everything with different series, we are going to talk about another very interesting topic. Okay, what happens, that is, we discussed about things where we had two series and we were trying to add, subtract, or do any operations on both the series together, like S1 plus S2, S1 minus S2, right? What happens if we try to create a series with values S1 and trying to add a constant value 8 with it? I have S1 and I'm trying to add a constant value 8 with it. Okay, it's not a series, it's just a constant value. What will happen? It's very simple. Since it is a constant value, pandas is very smart. You might be thinking that when we are doing this, 8 should get added to the first value and then it's over. The other values will remain the same. No, pandas is so smart that since it is a constant value and you are trying to add it with a series, it will add the constant value to every element of the series. You see, if I print, you will find that 10 has now become 18, 20 has become 28, and 30 has become 38, and so on. Let's see, S3, let's print S3 now. If I print S3, I will find 18, 28, 38, 48, and 58. So we have got to know that when we try to add or operate on a series with a constant value, it will give me a series with that constant value added to all the elements in the data series. Okay, so these are some of the basic operations which we discussed about. There are some more operations I want to talk about. Suppose, okay, let's do it this way. First of all, I want to discuss about summing or addition of all the elements in the series. Okay, if we have a series S1 and we want to add all the elements inside the series and find the total sum, what does the series contain? The total sum of the series which contains. Okay, so how do we do it? It's very simple. We just write print S1 dot sum and we are done. S1 dot sum and we are done. This will provide me the sum of all the values inside S1, that is 10 plus 20 plus 30 plus 40 plus 50. Okay, am I making myself clear? So this will be 150. Let's see answer is 150 or not. Yes, the answer is 150. Similarly, another function which I want to show you, which also is an operation of some kind, is if you are trying to find the average of the values. So for average, we do not use AVG. Here we use mean. Okay, we try to use mean and we find that the mean is 30.0. Why? Because it is adding up all the values and then dividing it with 5. Because there are 5 elements. And since there are 5 elements, it is dividing, it is using a float division. And that is why the answer is coming as a float, that is 30.0. Okay, the same thing will happen with any kind of series. So these are the two other operations I wanted to talk about. Okay, there are other operations as well. If you want to go into the details of data series, you can go to the documentation of Python, the documentation of data series in there, and you can find the other operations which are available, the other functions which are available in data series. But these are basically, I'm not discussing those because I'm going to discuss those same functionalities when we are doing data frame. So the functionalities are almost similar, so that is why I'm not discussing it here. We'll discuss it in data frames. Now what we're going to do is, when we discussed about data series, we have not discussed about one very important thing. That is, when we were doing data series, suppose we have a data series S1 and we wanted to print S1. So what we were doing, we were just printing the complete series S1. And we said that when we wanted to print a specific value from it, we had to provide the index position, right? So this index position is different from the index label which is present here. Okay, you have to keep in mind these index positions, these are index labels and this is index position. I don't remember that I have discussed about this when I was doing the video before, but I'm still repeating it once more. If I have discussed them, then this will be one kind of a revision. If I have not discussed this, then please listen to it now. See, when we are discussing about indexes, if the index values are numeric in nature, then these are just as index labels which get printed. But when we are saying S1 3, so it will count the values from 0 only, 0, 1, 2 and 3. So it will S1 3 will print 40. Let's see if it prints 40 or not. Okay, so it is printing 30. Okay, so I was wrong. So S1 3 is basically printing this index position 3. Okay, this index position 3. So index position 3 contains 30, and that is why it is printing 30. Okay, so while we are giving this index value, uh, we basically have this label, and when we are trying to print it, this will print the index labels. It will print the positions of the index labels, but it will also print, suppose if we have S2 and we are printing S2 3, like now you can say that S2 3 will print NA because 3 is not present. But since 3 is not present, it will try to find it in the 3, and if it is not finding, then it will use the original index positions. So I think it will print 4 here. Let's see. No, it is giving me a key error. It is giving me a key error, and it is saying that position 3 is not available. Okay, so it is giving me a key error that whichever key which you have provided is not present in the index. But if I change these index values from numeric values to suppose strings or characters, okay, if we change that and now we try to print it, then it prints 4. Why does it print 4 now? Because these are specific labels which are provided, and these labels are string type in nature. So although these labels are string type in nature, it is basically built over the actual index position 0, 1, 2, 3, 4. Okay, so it is basically a label which is put to the actual indexes 0, 1, 2, 3 and 4. When we are giving numeric indexes, it will take the index values as the index labels. Okay, the index values will be changed according to the index labels. But when we are using character literals as indexes like A, B, C, D, E, or as we did earlier, Sachin, Ganguly, Dhoni, so what it does is it basically uses that as a sticker, as a label over the actual index positions. So the actual index position will also be available at that point, as well as the index values provided here, the index labels which are provided here. So if we want to print 4, we can either write S2 3 because the position is 0, 1, 2 and 3, but we can also write where is the, 4 present in according to the label at position D, right? The index label D. So if we do that, then also 4 will be printed. At both the places 4 will be printed. Why? Because D is also correct, D is also correct, and position 3 is also correct. Both the things will give me 4, the value 4. Why? Because they are labels, one above the another, which is there. Both are correct. At this point, both are correct. Okay, am I making myself clear? Okay, great, awesome. Now, you remember when we discussed, you remember that, that in Python, there is a concept which is known as slicing, right? Slicing is available in Pandas series as well. So if we are basically trying to slice this, this value, slice this, this series, then we can do that. The same thing can be done using the exact same methods as we did in Python pandas, normal Python lists or tuples. We could do slicing there. We can do slicing here also. Let us give it an example. Suppose we are working with S1 and we are slicing it from, okay, here the thing is different. Let me see if I can get it right. If I'm trying to slice it from 1 till 3, so my output, according to the labels, there are two possibilities. One, we are using the labels, another we are using the actual index values. I think here it will use the actual index values and not the labels. Let us see. 1, 2, 3, 4, 5. These are the index values which are present, and I want to slice it from 1 to 3. So according to index positions, according to the index labels, which is this, if you are trying to find the output should be 10, 20, and 30 should not appear because we know that it goes from start to end minus 1. In slicing, right? We know this, that for slicing, it goes from start to end minus 1. So in this case, it can be 10 and 20 because 1 to 3. But if we are looking at it from the index position, actual index position perspective, where the actual index position starts from 0, the output can be 20 and 30 because this is 1, this is 2, and this is 3. 48 is at position 3. Okay, let me write it. This is at index position 0, this is at index position 1, this is index position 2, 3, and 4. Okay, so what will be printed? 20 and 30 will be printed according to the actual index positions, but the index labels are 1, 2, 3, 4, 5. So according to that, the value should be 10 and 20. Let us see what is the output. See, the output is 20 and 30. So while slicing, it is basically using the actual index positions 0, 1, 2, 3, and 4. It is not taking into account the index labels. Okay, but the index labels are not taken into account only for numeric index labels. If you are working with index labels of string type or a character data type, there both the things will work. The actual index positions, like here, if we have the actual index position as 0, 1, 2, 3, and 4, these index positions will also work and the index labels will also work. So if we are writing 1 to 4 for S2, so the output should be 2, 3, and 4. These are the three outputs we should get, and we will get the three outputs 2, 3, and 4 with the index labels B, C, and D. But the same thing can be achieved using index labels as well. But you have to keep in mind there's one more trick to it. The trick is when we're using index labels, then we have to give the exact starting point to the exact ending point. For labels, the exact starting and ending point should be mentioned. It should not be ending minus 1. So if we are trying to print 2, 3, and 4, so we should give from B to D. B, C, and D. These are the three things which will be printed here. For labels, the thing works as starting to ending. It doesn't work from starting to ending minus 1. So it won't stop before D. It will stop at D. Okay, let's see. C. B, C, and D. These are the three labels for which we wanted to print the series, and that is why it is printed as B, C, and D. B till D. B, C, and it will also include D. It will not end at ending minus 1 if string labels slicing works as start to end. Okay, let's put it here. If string labels, then slicing works as start to end. So we have to keep that in mind. Okay, so this is one way of doing slicing, but this can look a little bit okay. If you are wanting to find something from between the series, we can do it like this. But we have another thing is that for the same rules for the normal index values for slicing applies here also. If you are trying to print something from the starting of S1, or S2 from the starting till suppose position 3 from the starting. So we may or may not provide the starting value because it will automatically take it. Similarly, for index positions, I don't know if index labels are working. Let me check. Yes, index labels are working. So if you are not providing the starting value, it will automatically consider the starting position of the series as the starting value. Similar for the case of the ending value as well. If we provide the starting value as B and the ending value is not provided, so it will go till the end. B, C, D, and E. It will go till the end. Okay. So all the logics of slicing in normal Python is applicable in Python pandas series as well. Okay. Okay, great. But for doing this, we have some easier methods in pandas. Okay, two methods I want to discuss about. One is head method. Second is tail method. These are the two methods which are there. So this head method is basically nothing but it prints, it takes one value as input n and it prints n values or n rows from the top of the series. N rows from the top of the series. Or rather we should say the first n rows from the top of the series. Why am I saying this? Why am I saying first n rows? I'll explain it to you when I explain tail. You will get to understand why am I saying first n rows. The tail is basically similar to head. It prints last n rows, but from the top to bottom. Okay, so it will, so if I'm writing, I'm giving you an example. Okay, for head, if we write print s1 dot head 3, so we can basically understand that s1 dot head 3 will print 10, 20 and 30, 3 values from the top of the list. Okay, let me delete this. So it will print basically the top 3 values of s1, 10, 20 and 30. But if we are writing print tail or s1 dot tail, s2 dot tail 3, if we are writing s2 dot tail 3, so what it would do, it would print 3, 4 and 5, but not in the order of 5, 4 and 3. It will order 3, 4 and 5 because top to bottom it will print. Okay, it will print from top to bottom, but the last three elements top to bottom, the last three elements from top to bottom, see 3, 4 and 5, C3, D4, E5, this will be printed like this. Okay, am I making myself clear? These are basically some of the topics which I wanted to cover. There are other small functions as well which we can use, but I don't want to discuss them. These are not, they are not that important, as these are head and tail are the most important slicing techniques which are used for data series. There are others as well like LOC, ILOC, these things are also there. I'm not going to discuss them because they are a little bit more complicated and it is not that important from the perspective of board examinations. Okay, if I find those topics to be important, then in my next video, before I start data frame, I will discuss those topics and then move on to it, if I find that these are important. For now, I don't think that those are really that important that you need to know them. These topics like the slicing, the basic operations on data series, how to initialize them, and these functions, the small functions head and tail, are enough for someone to score really good marks in data series. Now, I can assure you that before I give my next video, I will post another video in between which will contain assignments. Some assignments based on data series, specifically on different operations and different things of data series. I will post a video which will only discuss about 5 questions, and then I will just give